Hello, and welcome to the podcast where friends discuss environmental policies from around the planet.
Hello, and welcome back to another episode by the Planet Policy Pals podcast. I'm Ajwa, and I'm joined here with my fellow co-host, Ala. Hey girl, what up?
Hey, what's up?
Not much. What's up with you?
Not much. I'm good. Chilling. Life, whatever.
That's always good to hear.
Yeah.
Life is beating you down.
Oh my God. Yeah.
Okay.
Rejoice in my pain, Ajwa.
Yes, I am very happy that I'm not the only one in pain. Let's all be in it.
Oh God.
But anyway, today we are going to be talking about pretty much what we talked about in the last episode, except like the things that we couldn't cover in the last episode, like the sea level rise. It's a very hot topic, and we are very excited to talk about it.
Mm-hmm.
So we are going to be talking about still the polar ice caps melting, and while we can cover so much on that, we have decided to break it into 2 episodes, and now it's the second one. But before we jump into the episode, I want to talk about this quick environmental news, which is the bomb cyclone that has taken over the northeastern region of the U.S. There's literally stunned iguanas that are falling out of trees in Florida because of the cold. They're not dead, guys. They're just stunned of the cold.
Poor iguanas.
Honestly, it's so bad. Like in Boston, in New York, there's just so much ice. But what is a bomb cyclone? Well, what makes a storm a bomb is how fast the atmospheric pressure falls, and this falling pressure is basically a characteristic of all storms. So by definition, the barometric pressure, it must fall by at least 24 millibars in 24 hours for a storm to be called a bomb cyclone. And the formation of this storm is actually called a bombogenesis.
Big word right there, huh?
So the deep drops in the pressure, they occur when there's a region of warm air that meets one of cold air. This air then starts to move, and the rotation of the earth, it creates a cyclonic effect. Now the direction is counterclockwise in the northern hemisphere, especially when we are viewing it from above. And that leads to winds that come out of the northeast, or as they call it, a nor'easter.
I think it all comes down to the jet streams. And just so everyone knows, jet streams are the narrow bands of strong wind in the upper levels of the atmosphere, and they're between the hot and the cold air. So then the wind blows from west to east in jet streams, but the flow will sometimes shift north to south, so it's up and down instead, and it covers large distances. And so you can have changes in weather and climate in one region like the Arctic, for example, affecting another region like Texas or Florida. I honestly think that we're just going to keep seeing colder and colder winters. There are a lot of other details in this, but that's just one of them. I think it's only going to get worse if we don't do something.
Yeah. Well, fingers crossed, and please keep warm if you're listening to us from one of those regions. It is not a fun time from what we see.
I know, right?
Yeah. So in the last episode, we talked about like the history and where like climate change even started to be measured. But in this one, we're going to be talking about the future and what are the scientific models that we're seeing around the issue. Okay. So scientists have come up with some models, and they're actually pretty cool. So one of the models that they've really worked on is the Greenland ice sheet, and that one is like rapidly melting, and it has already lost something like 3.8 trillion tons of ice just between 1992 and 2018. And that's the new study that they've found from NASA and the European Space Agency. Now, this study obviously combined 26 independent satellite data sets so that they could track the global warming's effects on Greenland. Now, this is also, again, let me remind you, one of the largest ice sheets on Earth, and it really impacts rising sea levels. Now, the findings forecasted an approximate 3 to 5 inches, which is something about 70 to 130 millimeters of global sea level rise by 2100. And they are very much in line with what they have shown in the previous worst-case projections if the average rate of Greenland's ice loss actually continues.
I mean, that means we have really dire situations coming up all in all, how will this melting ice affect the sea levels?
Okay, so as we know that as ice melts and becomes water, the volume of water gets displaced, which is relative to the volume of water that it would contribute to as melting occurs. So when sea ice melts, there is no change, right? Because it is already displacing that amount of water. However, with land ice, the ice isn't actually displacing any water. Right? So when that melts, it is additional water that is being added into the ocean, which causes the sea levels to rise.
Yeah.
Yeah. Now, this is why we have to care about the Greenland and Antarctic ice sheets, right? Because that's land ice, and which means that they directly impact global sea levels. Increasing rates of global warming, they have really accelerated Greenland's ice mass loss. It used to be from 25 billion tons per year in the 1990s to right now, which is a current average of 234 billion tons per year. That's what we're losing.
That's insane. So what is this in terms of like rates and stuff?
Okay, so this means that Greenland's ice is melting on average 7 times faster than it was at the beginning of the study period, right? And remember, like this ice sheet, it holds enough water to raise the sea level by 24 feet.
Well,
that's like 7.4 meters.
Well, at least it won't all melt, hopefully. So... But that's still so much ice.
You don't need it all to melt. Of course, we'll come back to it in a bit.
A lot of people don't think about how many countries are close enough to the Arctic to be affected directly. They're not even that far from the Arctic. So the sea levels affect you almost immediately.
Especially the Arctic and Greenland melting really does affect New York City, let's say, right? So land... actually like mass, it pulls water towards you or it pulls water away from you. Usually land pulls water towards it, right? But ice pulls water a lot more towards it. So Greenland was pulling a lot of the water, and so is Antarctica pulling a lot of water. But when Greenland is melting, a lot of that water is now just kind of balancing out and going to the rest of the ocean. And where it ends up is New York City around that coast. Even stretching down that entire like East Coast. Yeah, East Coast is honestly kind of like if ice melts, East Coast is the worst place to be. Also because there's so much about currents, right? Like the way that cold currents move up and warm currents move down. It is all just going to be kind of concentrated at the East Coast. So the worst part, honestly, is that like New York City is going to be really impacted if you really don't make a change. Yeah. This is why coastal research is so important. It really is. So Allah's out here doing God's work. Oh, you guys stop. I didn't mean to bring attention to myself. How did that happen? What? Of course, not at all. She didn't. So Greenland is losing a lot of water. It has added, if you really want to know in rates and fun numbers, if it all melted, it would add something like 120 million Olympic-sized swimming pools to the ocean every year for like 26 years. That's a lot. Yeah, like if you really want to know, so like as a rule of thumb, for every centimeter rise in global sea level, another 6 million people are exposed to coastal flooding around the planet. So... I told you how much we've lost, right? So on current trends, Greenland ice melting causes 100 million people to be flooded each year by the end of the century. And so in total, it'll be something like 400 million people in total due to sea level rise. We are going to run out of places to live. So like in addition to all these storm surges and high tides that will obviously increase flooding in many regions, sea level rise will also like exacerbate events like hurricanes, right? Yeah. Yeah. But we have to understand that sea levels rising are way more than melting ice. Like obviously when we get warmer temperatures, land temperature goes up, there's more precipitation because of it. Then there's also obviously as the water within the oceans, as that heats up, the water expands. So there's a lot of reasons for why sea levels are rising, but the ice melting is not helping at all. No, I bet. So we've talked a lot about, the melting and the sea levels rising like we promised. But I know you mentioned Greenland a lot, and that's pretty much the Arctic. What is the difference between the Arctic and Antarctica? Okay, so the primary difference between the Arctic and Antarctica is geographical, right? The Arctic is an ocean which is covered by a thin layer of perennial sea ice, and it is surrounded by land. Antarctica, on the other hand, it is a continent which has land, and it is covered by a very thick ice cap, and it is surrounded by a rim of sea ice and the Southern Ocean. Now, the polar ice, when you talk about polar ice, that is both, right? That's sea ice and land ice.
Right.
The most basic difference for them is that sea ice forms from salty ocean water, whereas land ice is actually fresh water, right? Like these are ice sheets and glaciers, and they're formed from fresh water or snow.
Okay.
And you know when they call ice sheets melting, those are land ice. When they call ice shelves melting, that's sea ice. Now, ice shelves melting, so remember how you talked about refrigeration quality of the poles for us?
Right.
So the ice shells are a lot more of a refrigeration quality for us, right? Because they have a lot more reflective surface.
Sure, because they're much more white, aren't they?
Yeah, so that's ice shells. And the sea ice, it forms in the winter months and it melts in the summer months. However, in certain regions around the globe, they do remain year-round. And roughly about 15% of the world's oceans, they are covered by sea ice during at least some portion of the year.
That's interesting.
Yeah, so roughly about 80% of the sunlight that actually hits the surface, it actually gets reflected back into space. But that's a problem, right? When it melts, it's not reflecting that much heat. And instead, the ocean absorbs 90% of the sunlight. And if the ocean is absorbing heat, it's obviously going to lead to more ice melting. So there's like this positive climate feedback, which is part of why climate change effects are really hard to predict, right? Because one thing leads to another, which leads to another, but that thing leads to the first thing. So it's like really a bad loop. For scientists, it is not easy to predict what causes what.
This is pretty crazy. I mean, we have global warming, that feedback loop, of course, the rising sea levels. Are there any other consequences than just rising sea levels due to the sea ice melting?
Well, of course, there's a lot more consequences than just sea level rising because of the ice melting. There's differences in salinity and temperature that impact global ocean circulation, like I talked about earlier, how water is just going to accumulate around the east coast. Then, also, these variations in ocean temperature and salinity also disrupt and threaten marine species that are dependent on the ocean because ocean, obviously, is very delicate to change. Now, fresh water is less dense than salt water, and warm water is less dense than cold water. Now, these differences obviously cause circulation in the ocean, and it causes some phenomena which is known as the thermohaline circulation.
Can I just say, you've been using a lot of big words today, girl.
Girl, do you know how much I spent like 5 hours just looking at videos because then I realized that I've just gone down a deep hole. I'm like, I don't really need to know. Do you know how many projections and how many models I saw of what will happen if all the ice sea melts? By the way, it's not going to happen. But you know, if it does.
If it does.
But Ala, should we talk about what will happen if the sea levels do rise and how that will impact us?
Yeah, so the two things I'm going to focus on are ground and freshwater, basically our water sources. So first of all, let's talk about the depletion perspective. So when glaciers melt, that affects river runoff, right? Because obviously you're going to get more fresh water because as Ajwa explained, when land ice is melting, you're getting fresh water from, sea ice, one of them, you're getting freshwater resources from them, which is available to people in communities. Land ice. I was right the first time. Okay. So not only to the glacier, but also far from the areas that have glaciers, you get this water. So as they shrink in response to warmer climate, at first you're getting a ton of water from this long-term glacial storage. And that seems cool, right? Because you get a ton at first. However, there's a turning point, which is called like the peak water point. And after this point, you get a huge drop. In fact, in the Andes Mountains, around the Andes Mountains in Chile, they're having this problem where they have like these insane droughts and then they have water in different seasons. And for a few years, they were getting water from the Andes and now they're not getting water at all. So it's become a real issue up there. The other thing you have to think about is contamination, right? So like Ajwa said last episode, one of the reasons we don't want permafrost to melt is because permafrost has a lot of old-timey stuff in there, apart from gases and microbes and things like that. So ice sheets, ice shelves, glaciers, permafrost, whatever, ice absorbs atmospheric gases and they store contaminants in them. They also store contaminants from other areas, especially in this Arctic region. There's a lot of human beings around, so we get things from mines, metal processing facilities, factories, oil and gas drilling, waste dumps, and sediments. And all that stuff adds to the local load of contaminants.
Oh, wow.
Yeah.
Big impact.
Mm-hmm. So the reason this matters is because, of course, one, you can have water-soluble contaminants from these processes that are carried into the river from that runoff when snow melts. For example, organophosphates are super soluble. They're like 80 to 90% soluble in water, and they're super harmful to humans. But you can also find other things there as well, like arsenic and metallic substances. But besides things that are water soluble, compounds, like I said, metallic stuff like arsenic can end up in your soil and your sediment. And the problem with this, apart from the fact that you just don't want that in your soil, is that the fate and transport of these kind of compounds depends on a mix of like transport mechanisms of the fluids as well as the soil. So it can be hard to trace where it's going to end up. It could end up in your groundwater sources. It could end up in your food when you eat it, if you use that soil for anything. I have an example.
Of course you do. So cute.
Yes, I am cute. Thank you. But there's this cool article that came out last year in Nature Geoscience. Please forgive me, these two scientists. Meyer Bachtal, Harper, and an international team of researchers discovered something that is groundbreaking. Maybe just for us, because we're environmental geeks, whatever. But it's like, we've always known from studying areas covered by ice over 10,000 years ago that melting of the ice affects groundwater over like thousands of years. But in their new research, they found out that the fluid pressure from ice mass loss makes the hydraulic head changes far more rapid and sensitive than previously thought. So simply put, what's happening is that ongoing and future ice thinning will reduce groundwater discharge rates, and that will impact the freshwater discharge, the freshwater delivery to fjords, and biogeochemical fluxes in the Arctic.
Oh, what do these words exactly mean? Talking about me using big words, girl.
So yeah, well, the biogeochemical fluxes just sound way more complicated than they are. It's basically just amount of material moved from one reservoir in nature to another. For example, if the amount of water lost from the ocean to the atmosphere by evaporation, that sort of thing. And you don't really want to mess with that balance. That's not something you want to mess with. Groundwater discharge is important because it's basically the rate at which your drinking water supplies and aquifers moves from the subsurface to the surface. And when it changes, it can affect your access to drinking water. And fjords are technically estuaries in glaciers or near glaciers, and these regions are very important for land and sea environments, and they provide habitats for humans in terms of like seaports, tourism, that sort of thing, but also for a lot of wildlife. So those are just some things to think about besides, some of the things that Ajwa mentioned. But of course, sea level rise is super important, and one of the reasons it's important is coastal lines, right, Ajwa?
Yes, and apparently every third thing that Allah said was based off of mine. I heard more of my name than I heard ice caps.
What are you talking about? Because it referenced last episode.
I know, I'm kidding. But no, you're right. It can have such a massive impact. So sea level rise will obviously reshape coastlines. So if you live on the beach, you may not be living on the beach for long, because incoming water, it floods dry areas. It erodes all these coastal features like beaches and cliffs and dunes. Now this obviously already occurs when you see these big storms, but these sea level rises will actually cause more drastic changes, because as waves reach further inland, they can actually inundate wetlands, and they kill the marsh grass, which actually holds the sediment in place. These grasses and animals that live in these marshes, they also help filter and stabilize these shorelines, right? And they provide this habitat for a variety of mammals, fish, shellfish, and amphibians. And they also have a migratory waterfowl. So now when we have without grass as an anchor, right, like now the sediment and mud is going to be pulled to sea or even like pushed further inland. They're quite resilient, unlike the beaches.
It's true.
And they are actually capable of moving up and inland when they're threatened by sea level rise, right? Especially if they have the space.
Yeah.
But many coasts, they have physical barriers that would impede this adaptation. That's what Allah is working on to fix for us.
Okay. Oh my God. You guys, my job is not that important. I just want to put that out there. It's important, but like it's okay.
Mm-hmm. Now, sandy beaches, they will obviously constantly change as waves and currents and tides, like they're going to carry all the sand and sediment from and to the shore. But when the sea level rises happen on an undeveloped beach, these natural processes, they push the beachfront towards the land. But as you know, there are actually many homes and businesses that are behind the beach that will prevent the beach from moving inland. But they found that according to California Sea Grant, nearly 60% of California's sandy shoreline is not able to migrate inward because it is actually bordered by man-made structures. So even if they want to move inland, they can't really because we've actually built there. And now I know you all are thinking seawalls. Well, seawalls and other offshore structures may actually interfere with the natural systems that manage this beach erosion.
That's actually a really key point. In fact, in the state of Texas, which, Ajwa, you might be stunned to learn this, but has very good environmental laws, I will have you know.
Okay.
When you do restoration along the coast, you're not allowed to use any sort of things that can't decompose, which is why most of the restoration is done using like vegetation and basically geotechnical ways of reshaping the dunes and things like that, or organic geotechnical materials along the beach.
That's pretty cool. Credit where it's due. So Texan women, if there's one other thing that you're worried about that white men care about more than you, it is the environment now. Yay. Hey, I'd rather be a beach in Texas than be a woman.
Oh, wow.
But in the United States, actually almost 40% of the population lives in relatively high population density coastal areas. So the sea levels play a very important role in flooding, shoreline erosion, and hazards from storms. Globally, though, 8 of the world's 10 largest cities are near a coast because that's where humans, that's where they settle.
That's true. Living near a coast is nice until global warming drives you away and flooding because you no longer have any floodplains left.
Yeah. Sea levels rise so now that's a problem, right? Like they're not even sea level rise. Like it's not like, what's happening in, let's say, Nigeria is going to be the same that's happening in, let's say, Karachi, or it's going to be the same that's happening in New York. Because if there's different terrain on land, there's obviously different terrain under the ocean as well.
Of course.
But also the way that sea currents move and everything. By the year 2100, swollen seas and these rivers will redraw shorelines as we see these climbing temperatures and these melting ice caps. In fact, in one of the most extreme scenarios, waters globally could rise by as much as 8 feet, and even a smaller amount of flooding could inundate low-lying areas of the coast. Now, in places like New York, which is home to around 8.6 million people, even moderate flooding could drastically impact the city's population and infrastructure. As we saw, like last summer, there were subways that were being flooded. There's just a lot that is happening, and these floods are not going to go away. Right? They're just going to get worse and worse. Europe was flooding last year. It was just a terrible place to be, the earth, last year. It was just not fun. So we really kind of need to see how important this is.
No, for real. I don't know. There's this environmental class I was taking, and we do these little flood models in Python or something. And he made us look up 15 cities across the U.S. It took a while because we had to look up a bunch to find the 15. But we ended up finding these historically flooded areas, and a lot of the areas that had major flooding and will continue to have major flooding also happen to be socially vulnerable areas. Not all of them, but quite a few. And I thought that was interesting. The fact that all of you who have nice beachfront homes will be homeless in a few years. Marine life will also be homeless. So let's list off some of the marine life that will suffer from not having homes in the Arctic. First of all, polar bears, whom I love. Polar bears give birth and hunt on sea ice, and they need it to travel from one region to the other. So the mothers and cubs, they can't survive if the mothers cannot hunt. And that depends on the stability and extent of the sea ice. Remember how we might lose summer ice, you guys? What will the polar bears do? Something else that's going to be affected by summer ice? Some of the seal species that rarely come to land, like the harp seal, the spotted seal, this ringed seal. And they all depend on Arctic sea ice because the ice provides a home for resting, giving birth, and raising their little pups. And it's also where their feeding grounds are located. Some seabirds, such as ivory gulls and little auks, are very likely to be negatively impacted by the decline of sea ice and subsequent changes to the communities in which they live. In fact, a lot of huge declines have already been observed in ivory gull populations, including an estimated 90% reduction in Canada over the past 20 years, which that's a lot, you guys.
That is a lot. Damn.
Exactly. The loss of ice in the Arctic could also reduce the large catch, about 100,000 tons a year, of northern shrimp currently taken from Greenlandic waters. Furthermore, northern shrimp are a huge part of cod diet in Greenland. So even though, I don't know if you know this, fun fact, cod have actually been growing in Greenland recently, the lack of food will definitely affect them and will cause those numbers to drop.
Okay, well, that's the problems. Do we see any solutions? Any policy solutions? Any that work, at least.
Right? That's the key word. Any that work. But the Arctic region is a geographical area that comprises of 8 countries, including 5 coastal states, and they all share jurisdiction over parts of the Arctic Ocean. So if you guys want to know more about these countries, check out arcticportal.org, because I'm not going to list all of them. There's a lot of laws. They're international, there's collaborations between them, and there's domestic. But I'm going to list like 2 that I kind of like, 2 that I want to bring attention to, policies, things like that. There's the Inuit Arctic policy, and that is worked on by the Inuit Circumpolar Council. So the ICC, not that ICC, but the Inuit one, holds a general assembly every 4 years, and they have delegates, and they elect chairs and executive council, that whole shebang. And when they do that, they develop policies and adopt resolutions, and their kind of goal is really to focus on what will help the indigenous Inuit people covering Greenland, the US, Russia, and Canada. It's a very international group, and the Arctic Council that's under the group, they work in getting recommendations that are environmentally and socially affecting the Arctic. I think the thing that's really interesting about the policies that they work on is that they always tie in the human components, and obviously they're indigenous people, so they're going to care about indigenous rights, which I think is really important.
At least somebody is.
Right? It's important that somebody does. The second one is actually from Finland. Big fan of this. It's called the Finland Strategy for the Arctic Region. It was adopted by the Finnish Cabinet Committee on the EU in June 2010. They updated it in 2013, most recently in 2021. Now, the thing that I found cool from their most recent update was that the whole of Finland is now considered an Arctic country, like the entire country.
Yeah, might as well. What's the fight?
I know, right? But the reason they did it was that they said that Finland's Arctic interests and Arctic expertise affects the whole country. So they're recognizing that Finland's Arcticness supports and strengthens Finland's international Arctic country brand and international contexts. The point is to make the environmental commitment to protecting the Arctic region located in and close to Finland even stronger. And I think that this will work. I think it also gives them like leverage just in the international relations going on in this region, because as we will see, they're not great, you guys. Like, these people do not get along when it comes to the Arctic.
I mean, let's be real. The world does not get along when it comes to anything.
Yeah. I mean, even here in the US, if you guys remember the whole thing trying to save in the US, trying to save the ANRW over here. And that's been a whole thing. That's been a fight for years. But anyway, let's talk about what doesn't work. And it's just going to be one thing, and it's international. It's called the United Nations Convention on the Law of the Sea, or I'm just going to call it UNCLOS. And they offer general norms that govern the Arctic region, including the rights and responsibilities of both coastal and non-coastal areas within and beyond national jurisdictions. By virtue of the law of the sea, the coastal states have sovereignty over their territorial seas, which is 12 nautical miles. I don't know how much that is in real people miles, and certain exclusive jurisdictional rights within 200 nautical miles of the coastline. To be honest, this is beyond a great example of field policy because nobody ever complies with it. They have a serious non-compliance issue. First of all, the U.S. refuses to sign, despite the fact that the country plays a major role in contributing to the issues outlined in the convention. And the U.S. is geographically an Arctic state along with Canada, Denmark, Finland, Iceland, Norway, Sweden, and the Russian Federation, but they won't sign it. So I don't know.
Am I surprised? Are you surprised? Is anybody surprised?
I know, right? No one's surprised. I think it's so that like when they have massive oil spills and things, they can just get away with it. That's my take.
It's to defend themselves for whatever future havoc they're about to wreak.
Yeah, that's how I see it. Speaking of non-compliance, in November of 2017, 9 nations, including all 5 Arctic coastal states, along with 4 of the non-Arctic states, that was China, Japan, Singapore, and South Korea, and the EU, they all came together. They concluded an agreement to ban unregulated fishing in the Central Arctic Ocean for at least the next 16 years, pending the availability of more concrete knowledge on the marine ecology of the Arctic high seas. That was in 2017. By 2019, China wrote a white paper on how it is a near Arctic state. And basically they were like, no, we no longer want to honor this agreement. But they already signed it. And like, UNCLOS couldn't do shit. Yeah, exactly. That's my problem. It just doesn't make anyone do anything. So that's why I think it's kind of silly. And the last thing, I mean, there's a lot of other things wrong with it, but one thing I really don't like about it is what we call the Exclusive Economic Zone, the EEZ. I know a lot of people have heard about this, and it annoys me, but it basically recognizes the right of coastal states to jurisdiction over the resources of 38 million square nautical miles of ocean space. And when it was developed, everybody thought it was just the bee's knees. Everybody thought it was hot shit. They loved it. But the coastal states gets the right to exploit, develop, manage, and conserve all resources, fish or oil, gas or gravel, nodules or sulfur to be found in the waters, on the ocean floor, and in the subsoil of an area extending 200 miles from its shore. Now, how could this possibly go wrong? I don't even know how they thought it would go right. Do you remember when we did that fishing episode and we had this issue where we talked about Japan and the fishing in the EEZ? Exactly. So that was an EEZ problem. Of course, China versus US with the military ships, that's an EEZ problem. All bad for global relations and bad for the environment. Just things for us to think about. You know what I mean?
Good for the egos, though.
Always for the egos. So let's look to the future.
Well, what do you think the future is going to be with a present shape like this?
Bleak.
Yeah, but like, okay, so I know everybody asks this one question. Will the whole Earth ever be underwater? No. Short answer, right? And all the ice is not going to melt either. So that's also not happening. The Antarctic ice cap that we keep talking about, where most of the ice exists, it has survived way warmer times, okay? But the problem is that if all the ice that was covering Antarctica, Greenland, and in mountain glaciers around the world, let's say they were to melt, sea levels would rise about 70 meters, which is 230 feet. Right? The ocean would cover all the coastal cities and land area would shrink significantly. But many cities like Denver, they would still, survive, except you couldn't ski there anymore. They would probably be your beach town.
And also Denver is mad expensive. Can you imagine how expensive it'll be when it's the only city left?
Oh yeah. Denver already gives you a big finger. Imagine what they would do when they don't even have to care about it.
Oh my God.
You have nowhere else to go.
Yeah.
But the concerning part is that portions of of the Greenland and West Antarctic ice caps, they actually may disappear. We don't know how much or how quickly this could happen because we don't actually know how it will happen, right? Like, you have to understand, scientists are still just like measuring these things. Nature is vast, it is huge, and to understand every aspect of it is obviously not at all easy.
Of course.
We know that ice doesn't just melt, right? Ice actually flows down valleys like rivers of water. Now, the problem is that we don't completely understand the factors that control how rapidly this ice flows and how it enters the ocean. Now, one way that we can approach the problem of not understanding the process is to study how sea level changes in the past, right? Now, Earth is actually nearly as warm now as it was during the last interglacial period, which is about 125,000 years ago. Now, at that time, sea level was about 4 to 6 meters higher than what it is right now. Now, it seems that this higher sea level was due to the melting Greenland and West Antarctic ice caps. Now, like I said, Earth is not just like a stagnant ball, right? Like, it changes, it moves over millions and billions of years. We have seen Earth evolve and change the shape of Earth, how Earth, like, it has gone through ice age, it has gone through really high heat, but it still stands. The problem is we are kind of making it change faster, right? Like, we have a role to play in the Earth's changes, which we should not. Now, we do see a similar sea level rise in our future. We don't know. We also don't know how rapidly sea levels could rise. Like, will a 4 meter, which is something like a 13-foot increase, it would take like 200, 500, even like 1,000 years. We don't know this stuff. Now, this is a question that a number of scientists are really trying to answer by studying how ice moves. So maybe we'll find out.
Maybe we will.
Not right now, though. But they do have some things to say. Ala, what are they saying?
Well, same as last week and just what you said. This is a global warming and climate change issue. So the obvious solutions that most scientists and experts talk about is slowing down global warming. We also discussed geotechnical solutions in episode 34 last week. Please go listen, and they're the same for this episode, to be honest. The one thing that is unique in the Arctic, which we could definitely stop, is shipping, and it's relatively new. So due to the fact that ice is melting rapidly, ships can now pass in areas of the Arctic that they never could before. I hate to say it, and I know you always tell me not to tell them stuff like this, but this is really good for commerce and trade and money, as it makes transport faster and cheaper.
No, I believe, do tell them that if they can make it better.
However, it is awful for the environment, and I just don't think it's worth the cost, you guys. It's just not worth the cost, because the additional vessel traffic exposes wildlife and Arctic communities to new risks, increased pollution, ship strikes on marine mammals, the introduction of invasive species on the hull, oil spills, don't get me started, and of course interference with local hunters and fishermen who use small boats and have been there for just decades and sometimes over a century. That's just what they've been doing for a very long time. In fact, as an example, I have another example, Ajwa.
Yay!
The Northwest Passage in Canada can now carry out tourist expeditions. And while I know it sounds beautiful to be able to travel through what no one could pass before except like really specific type of ships,
it does not sound beautiful to me. It does not.
I know. It sounds hella cold, but a single large cruise ship will emit over 5 tons of NOx emissions, like nitrogen gas emissions, and 450 kilograms, of ultrafine particles a day. To give you an idea, that's about the same amount of sulfur dioxide as 3.6 million cars. So that's one thing scientists and activists are telling us to stand up against.
Oh, wow.
And I think that's an Arctic problem. That's not something you'll see in the Antarctic, So anyway, my biggest takeaway from this episode has been that the loss of summer ice bothers me a lot more than I realized, because I did not realize it would be this soon until we started researching for the episode from last week, As far as where I rank this, I'm going to rank it at an 8.5 because it's slightly higher than last week because it affects a lot more people. What about you? What's your rank?
Honestly, the same as last week because I feel like it's still the same issue. Ice caps melting, like I said, it's a loop.
Right.
Sea levels rising, flooding, hurricanes. It's just a whole bunch of development crisis. Yeah. Apocalypse.
That's fair. Audience, question for you guys. Of course, rank it. We want to know where you guys rank this stuff. But also, do you guys think Arctic states and near states will ever get along? Let us know. And if you, most likely your answer is no, let us know why that is. Organization to highlight. Ocean Conservancy, which is an organization I love. It's really cool. They work to protect our oceans by raising awareness. They do a bunch of stuff too. They demand like changing legislations. They work with governments to write policy. They do scientific research, public communication, sustainable fishing, and they protect the Arctic. They work closely with indigenous communities. They're just a great organization, so do check them out. Thanks for hanging out with us, you guys. We love doing this, and we love that you guys keep supporting us. It means everything. Of course, we would like you guys to please leave us reviews. I will never stop asking, guys. Rate us, leave us messages, and we will respond. Next week, we're going to have our anniversary episode. Ajwa, can you believe it's been a year?
I can't believe it. Oh my God.
I know, right? So, yeah, we're gonna it's a surprise. You guys just wait and see. It's our anniversary episode. Find us on Twitter at Planet Policy Pal, Instagram at Planet Policy Pals, like our Facebook page. Try to stay warm as we suffer through these cold fronts that, as explained in this episode, we kind of brought on ourselves as human beings. And until next time, keep learning how.